Greeting guys. So today's video is inspired by one of our awesome subscriber who have requested a topic on clustering using embedding. So we will be just clustering the random Wikipedia articles and this hands-on notebook which will help you to scrap the data from web, and then we will be doing the embedding of these articles, and then we will be applying KMeans to cluster these articles into a categories. So we will be using Python for to do this. So we will be exploring the process of clustering random Wikipedia articles using state-of-art text embedding techniques. So basically we'll be following a few key steps. So the one is like data collection. We developed a function to fetch random Wikipedia articles, so which will be efficient web scraping technique. And the second one is text embedding. So we use the powerful mini LM model from Hugging Face Transformer library to encode our article text into high dimensional vector space. And the third step is like dimensionality reduction. We will be applying PCA, which is principal component analysis, to reduce the dimensionality of our embeddings, making them suitable for visualization and clustering. And the fourth step is clustering. We employ like K-means clustering to group similar article together, revealing patterns in the Wikipedia corpus. And the fifth step is visualization. So we created interactive scatter plots using Plotly, allowing us to like visually inspect the clustering results and identify interesting patterns from them. So basically these are the key steps that we're going to follow in this notebook. I will be walking you through these steps one by one. And what are the key insights? So we'll be using mini LLM model from Hugging Face, which is highly effective in capturing semantic similarities between articles, and the clustering algorithm, which successfully identified like coherent groups of related topics across Wikipedia articles. And some clusters revealed unexpected connections between seemingly unrelated subjects, highlighting the power of like unsupervised learning in discovering hidden relationship. So we will be seeing it in the notebook later. And then what are the limitations that we have with this, I mean these approaches? The effectiveness of clustering heavily relies on the quality and diversity of the input articles, so I mean your input data. So future work could like involve creation of more pre-processed and focused data set, which would improve the clustering. And the current implementation, it just doesn't handle multilingual articles. So with this notebook, we will be seeing only for the articles which are in English, and expanding to support like multilingual approach could like greatly enhance the tool's utility. And then also incorporating domain specific knowledge or ontologies could potentially improve the accuracy of the clustering, of course. And then implication and potential application of this clustering using embedding would be adopted for various NLP tasks. You can take like document summarization, topic modeling, or personalized news feeds. So it will be used everywhere. And then in educational settings, so it could be assist in identifying core concept across different resources or textbooks. For researchers, it provides a quick way to explore the structure of vast corpora without manual annotations. So these are some of the application point of view for why we are doing clustering using embedding. So to start with the notebook, we have to install a library which is sentence form transformer, which doesn't come by default with Collab. So why we are using sentence transformer is for to like download our mini LLM model for to embed our articles. So let me install it. So you see the output in this notebook because I have already ran the notebook once to see everything is working as we need. So now we have installed sentence transformer. So once it's done, as I said, like we will be downloading the data from Wikipedia, and then we'll be applying the clustering, I mean K-means cluster technique. So let's import the necessary libraries that we need in order to do the web scraping, and then dimensionality reduction, and then for to do the clustering, and also visualizing the result at the end. Okay, so let's import all the necessary libraries. So now it's done. So once we are here, our next step would be like web scraping. Okay, so you have to scrap a few articles from Wikipedia, and we will be put it in data frame. So here we will be using get random Wikipedia articles, which will like scrap random articles from the special category from Wikipedia, and we will be doing some HTML parser using Beautiful Soup. So this is the library which is used in most of the web scraping technique, and then we will be just retrieving the first headings as a title of the articles, and then we will be getting the text of this response content, and then we will be returning the title text from this function. And once so this is a basic function to scrap the articles from the Wikipedia. And the second thing is here we won't be like retrieving all the articles from Wikipedia, where it's not like it's like really a huge task. So we will be just getting 20 random Wikipedia articles here. So we will be calling this Wikipedia article function that we have defined earlier for 20 articles, and we will be appending the result into the article list here. So once we have the articles list with title and text, and we will be creating the data frame with it. So let's run this cell to do the web scraping from Wikipedia, and then just get 20 articles from Wikipedia, and then put these articles into the data frame. So now it's done. It's time to see what we have scrapped. Okay, so to do that, we can just visualize the data frame head. So if you see here, it just has scrapped like titles and text. So as we mentioned here, we will be having 20 rows. So let me do like df.shape. Okay, there are 20 articles which are retrieved, and I would like to see the complete data frame that we have scrapped so far. So you do have few category like film, songs, and then a few philosophical content, and yeah, and also we do have a few articles from Olympics, and then and countries. Yeah, so there are I'm not aware of all these topics, but yeah, still, yeah, we have like variety of topics that have been like scrapped from the Wikipedia. And once we have that, what we have to do is we have to embed the text, article text, which are like in the text column. So for to embed this text, we need a embedding model. and then we will be encoding this text. Okay, so for that we have already installed sentence transformer. From sentence transformer we have also imported the sentence transform for hanging face, and yeah, we will be just looking for the model all mini LLM LM from a sentence transformer, and then we will be try to encode the data frame text with this model here. So we'll be applying to we will be applying the model to encode our text. And once we have our embeddings of the articles, we will be putting this into the data frame as like here in this line. Okay, so now we have created a new data frame which is DF cluster. And for information, now we will be just clustering these articles into two categories, only two clusters. Okay, so maybe you can change this later, and then you can test it as per your need. And also you can change the parameters like number of articles that you want to retrieve from Wikipedia in order to like test in detail. So for now, for the simplicity of this tutorial, I have just put like two articles, and we will be importing KMeans with number of cluster and then random state. So you can change this parameter as you will be doing your hyperparameter optimization in order to like adjust the clustering as per your need and as per the efficiency of the task that you are handling, and that's in your hand. And here we will be applying K-means, and we have to use the K-means model, and then we will be fitting this model against embeddings. And once we have our embedding classes, which are the output of this fit method, we will be putting these classes into the new column in the DF cluster that we have created earlier. So which is this column, which is cluster. So let's execute this cell to embed our model and apply KMeansClustering. So if you execute the notebook for first time, so it will be downloading the model, and then yeah, it will be applying the encoding process. So now it's done. As we are just using only 20 rows of articles, so it's like really fast to embed these 20 rows. And once we have this, and it's time to like visualize the clusters that we got from this, the cluster classes that we got from our K-means. So for to do that, I have already created a function which is generate chart. And what it's gonna do is it will take the DF and then X column and Y column as dimensions, and then text column, and then we will be using the clustering chart, and it will be help us to visualize the different cluster with different colors. So let me execute this, and we will come back to it once we will be using this generate chart in the later phase of our tutorial. So now we have our PCA. So PCA, why we use PCA is to apply the dimensional reduction for the visualization purpose. So it just simplifies the way we visualize our features. And then so normally when we deal with like text embeddings, so it's often high dimensional, which makes it difficult to plot or interpret. So that's where PCA comes in, and it reduces the dimensions of the data while keeping the most important informations. So in our case, we reduce the data to like just 2 dimension using PCA, allowing us to like visualize the clusters on a simple 2D scatter plot. And this is super useful because it shows how the different points, in our case it's title, are like separated or spread out and grouped into clusters. So with this 2D visualization, we can actually see the separation between the clusters and understand the relationship between different data points. So each points on the chart represent a title, and by coloring them based on the cluster they belong to, and we can easily see which points are like part of the same group, and because plus the text labels help identify the individual points on the plot. We have to fit this PCA with the embeddings that we have created earlier, and once we have it, we have to put the reduced dimension in a column which is 0 and 1, and we have to also put the data title from the original data frame to the DF cluster data frame. So once we are ready, we have to generate the chart with the following parameters. So I have to send our DF cluster as we see here, and then we will be sending the new column. So with the reduced dimensions and with the original title, and we will be doing the clustering, and yeah, we have to give the title for the chart as well. So now let's generate the chart for the clusters that we have generated with KMeans. Yeah, that's quite good. So we have two clusters. The first cluster which are like which can be identified with yellow dot mark, and then the second one will be with the dark dot mark. So if you see the 72 versions, belly charmer, and then crackdowns, these are the topics which are more common and close each other in terms of their semantic similarity, and other points are like more like they are like outliers to the zero, the zeroth cluster. So, in order to like experiment more on this approach, you can use more number of cluster to see how it just facilitate the clustering process. So now it's done. So I would like to just do another clustering with different random articles. Let's do it. Okay, for to do that, we can just re-execute the cell. That's enough. Let me re-execute this cell to like get some other like articles that will be different from the one that we have retrieved earlier. So let me execute the cell. So now let's see what are the data that we have retrieved so far. So we do have contents of the Independent School District and Daniel Wood, which is the writer profile, and then we will be having few authors profile, and then artist profiles. Yeah. So let me re-execute this to get data that could be like more well known, but I don't think that we can get it in a single try. We have to I'm really curious to get some data which are like well known to everyone, so that it will be like easier to understand as well. So we have a few data on bank robbery, hospital, and then departmental data, and then yeah, a few authors, and then as well the artists. Okay. Let's do our like clustering with this data, or let's see how it works. And for that, let me re-import the model from some instance form, and we have to encode the text using the newly retrieved text using this model, and then we will be applying the KMeans. So it's done now. Now it's time to like generate chat with the new clusters. So basically with our second try, you see just have two clusters, and then as we have mentioned earlier with our KMeans, and it just splitted the data into two categories. One is more on like cultural and musical entities, and then second one is around like geographical or historical entities. So if you see here Kajif, and this all this Valpens and then the Shogia are like more closely to the musical organization, and then notably they are the artistic name, and then also it just classical music name. Yeah, so if you see it just makes one cluster, and then put all other articles or entities into another cluster. So these are kind of entities which are around historical location events and references, or like geographical entities. Okay, so I think the KMeans is doing like a good job, and yeah, we have to experiment with more cluster, and then with PCA dimensional reduction method in more precise way to just like refine our result, and to get like better outcome from these approaches. So basically, if you see, these two clusters help us to organize the data into meaningful categories. So based on their primary association, and yeah, either it's cultural and musical aspect, or like historical and geographical significance. So clustering simplifies the data into distinct areas of focus for like further analysis or study. So this is what I really want to bring to you guys, and then to learn with me like how we can do the clustering using embedding. So regarding the further study, if you see this notebook, which just helps in understand large scale text corpora in like showcasing cutting edge model, and how we can just make use of these models to embed the data, and then maybe use it for like unsupervised tasks and revealing hidden patterns in seemingly unrelated text. And also the approach presented here like serves as a solid foundation for further exploration in natural language processing or machine learning application involving text data. And also experimenting with further study and experiment with other embedding models to compare the performance, that would be useful. And also implement more sophisticated clustering algorithms like dbscan or hierarchical clustering. You can make use of different algorithms in order to like do the benchmark on the result that we obtained, and then develop an interactive visualization which allows the user to like explore the clusters in real time. It can be done in the area of visualization, and yeah, if you are like going for like industrial based MVPs, you can develop a web interface to like make the tool accessible to non-technical user as well, and also explore the use of like techniques in specific domain with different legal documentation and scientific literature, or like social media post. You can apply with any data and do your clustering using embedding. So this is what I really want to bring to you guys, and yeah, we are at the end of this tutorial. Hope you find this video helpful, and thanks to the subscriber who just asked me to do this video. And it's an interesting topic, a leading topic that everyone should be aware of. And so if you like this video, do not hesitate to give it a thumbs up, and do not forget to subscribe to our channel. In the way you will be get notified whenever I upload a new video, and let me know what topics need to be covered in the upcoming session. Until then, this is Abunya. Bye for now. Thanks for watching.